Hello again, ladies and gentlemen. This is Mr. Arias, and my channel is Math to the Point. In today's class, we're going to be investigating the effect of k in a quadratic function that happens to be in vertex form. And again, just to recap, any quadratic function in vertex form has the following structure and the following equation. F of x is equal to a times x minus h to the power of 2 plus k, where the values of a, h, and k can be integers, decimals, or fractions, or any other type of number, basically. And for this value of k, we're going to have two cases, like when we investigated the value of h and its effect on this quadratic function. And technically speaking, case one is when k is bigger than 0, which means it's positive. So if that happens, the parent function, which we defined to be last time in the previous video as f of x is equal to x to the power of 2, will be experiencing a shift or a movement of k units going up along the y-axis. And for the second case, if the value of k is less than 0, which means it's negative, then the parent function will be shifted or moved down k units along the y-axis as well. Now, that being said, let's do a quick demonstration and then we can do an example. So I'm going to use the graphing calculator. And just to recap, this right here, ladies and gentlemen, is the parent function that I was talking about. F of x is equal to x to the power of 2. This is the most basic function that we have when we're talking about quadratic functions. And any other function in existence that happens to be quadratic is a variation of this function itself. So that being said, I'm going to show you an example in which we change the values of k. So let's do an example like this. Let's say that because we don't have a value of h, we don't have a parentheses. So we're going to basically have just x to the power of 2. Or technically speaking, that's as if we had, let's say, just x minus 0 or x plus 0. As you can see, there isn't any change because we don't have anything in that parentheses. And I'm going to just use the value of a as positive 1 because that's exactly the same one that we have in the parent function. Nothing really changes, right? So let's give it a try. If my value of that means that if, let's even make it more visual, I'm going to open the parentheses. Okay, so we don't have a value of h. We're going to investigate the outside value that's adding or subtracting to this parentheses, which is the value of k. Let's say that we add, I'm going to say 3 units, right, to this parentheses. Check what happens to the vertex of this new function. So the vertex of the parent function was located on the origin, which is at the point 0, 0. So now if I use the same parent function, but now I change or I increase the value of k to 3, what would happen is that this vertex is moved to create the new function, which is in blue. So now my vertex is at the coordinate 0, 3. So if you noticed, what changed was technically just the coordinate of that vertex, which is now lifted along the y-axis. Okay, so it basically changed 3 units. Now, if I decrease, instead, if I turn that k into negative, then we have the opposite effect. Now my vertex is located down there. So technically speaking, that happened as if this vertex of the parent function had been dragged down along the y-axis 3 units. So that's exactly what happens. That's the effect of k when it's positive or negative. And just to prove that in this case, we don't have these counterintuitive cases in which, like for example, with h, if I said in the previous video that if h seems to be positive in your equation of the quadratic function, in reality, it's originally negative. And if it's negative in that parenthesis of the equation, in reality, it was originally positive. That doesn't happen with k because of the following. So the equation of a quadratic function in vertex form has the following format, which is a times x minus h to the power of 2 plus k. So there's a plus symbol between the parentheses and k. So for example, if I choose a value of k that's positive, what would happen is this. Let's say that we choose a k to play with that is positive 3, like in these examples. And that means that I would have to take this k off and then I would replace it with positive 3. So we end up getting the following expression. We have this parentheses, and then we have a plus 3, right? So what ends up happening here is that because we have two positive symbols back to back, that doesn't change the original value of k. It's still going to be positive 3. And then we have the same structure of the other term. So we have a times x minus h to the power of 3. Okay, so nothing really happens. If k is positive, it's going to remain positive in the equation. Now, on the other hand, if I choose, let's say, a value of k that is negative, for example, let's say we choose a value of k that is like on the screen, a negative 3, then what's going to happen is that I have to replace that in my equation, and then we get the following. We have a plus minus 3, right? And then you end up having this plus and minus back to back. So in reality, when this happens, the plus does not affect the value of k because having a plus next to a minus reduces down to a minus. So technically speaking, that means that my k is going to be still negative, right? So pretty much I'm saying this because I want you to know that the value of k is pretty straightforward. If it appears to be positive in your equation, that means that the value of k was originally positive. Then you have this this shift along the y-axis going up. And if on the other hand, if the value of k was originally negative, it's going to appear as negative in the equation, which means that the parent function will be experiencing this drag along the y-axis, and it's going to be going down, as you can see here on the screen. Here we went down 3 units. Okay, that's it. Thank you for watching, ladies and gentlemen. Have a wonderful day, and I'll talk to you next time.